Hello everyone, welcome to your delayed Week 4 lecture in GV467, Introduction to Comparative Politics, and today we are talking about, per usual, an empirical topic and a methodological topic. The empirical topic is democratization, and the methodological topic is large N studies or statistical studies. As you will know, if you've perused the reading list, there are 4 readings for this week. The first 2 by Jaworski and Ross talk about the origins of democracy, or the things that explain democracy. And the latter 2 are methodological. The first of these, the one by West, is kind of a funny methodological piece because it is, in fact, a satirical statistical study. And as you will see, it's a very brief paper, and it tries to make the case that statistical studies sometimes lead to absurd results. And then the second piece by Peter Hall discusses reasons why you might not expect statistical studies to give good answers to the kinds of questions that people in comparative politics care about. So getting into democratization, what I'm going to try to do in this section of the lecture is take you through a little bit of the literature background that will help you understand better where the readings for this week are coming from and what arguments they were reacting to. It should not surprise you, given what you already know about the history of comparative politics, that scholars in comparative politics started talking about democracy in the framework of modernization theory, and one of the common conclusions of modernization theory was that democracy and modernity, or maybe economic development, go together. One of the earliest expressions of this thesis was set out by Alexis de Tocqueville, who visited America in the early 19th century and wrote a very famous book, actually 2 volumes, a famous book called Democracy in America. And what he saw as the big trend of history, remember in modernization theory, what you have is a historical trajectory. What he saw the historical trajectory being was one from a society in which there were sharp gradations of rank. For instance, Tocqueville himself was an aristocrat, so he considered himself and was treated as a very different kind of person than ordinary people. You were undergoing a transition from a society in which there were these sharp distinctions in rank into a society in which there was equality of condition. And what Tocqueville noticed or claimed was that this equality of condition was the coming thing, that you were seeing it more and more in the European countries and in his own France, even though it hasn't gotten in Europe as far as it's gotten in the United States. It is on its way. And you'll see that he refers to this equality of condition almost interchangeably with democracy. So he thinks of democracy as we would, as a system with voting and elections and so on and so forth, but he also thinks of democracy as a system in which there are not sharp distinctions of kind between different people. And he thinks that this trend towards equality and democracy is the direction of history. It is evident to all alike that a great democratic revolution is going on among us. It is not accidental, he says. It is irresistible. It is the most uniform, the most ancient, and the most permanent tendency to be found in history. Fast forward 120 years, and scholars in comparative politics were still reacting to and building on Tocqueville's thesis that change through history was giving rise to an equality of condition that gave rise to democracy. And the scholar Seymour Lipset, whom we already mentioned last week, set out in 1959 a very influential account, an account to which people are still reacting more than 50 years later, of the social requisites of democracy. And what he tried to argue is that more developed countries were also more democratic. So you can see then in this table drawn from his paper that as per capita income goes up, income is going up, you're moving from stable dictatorships to unstable dictatorships to unstable democracies, and finally to stable democracies. So there seems to be a trend of movement from dictatorship to democracy. Similarly, there's a trend in movement from dictatorship to democracy as the percentage of agriculture in a country's economy becomes less. So, in short, economic modernization leads to democratization. That's a correlation that Lipset observes, and it is a correlation that still is quite powerfully observed in the world today. Now, just because richer countries are more democratic does not mean that they are more democratic because they are richer. However, it seemed to Lipset that there was a causal relationship here, and he tried to explain why economic development might lead to democratization. And one of the key causal mechanisms he argued for, was the idea that economic development spreads wealth. Why should the spreading of wealth through economic development contribute to democracy? Well, Lipset gave 4 reasons. First of all, he says if you have a highly concentrated income distribution, so one in which there's a lot of wealth concentrated in a few hands, Lipset thinks you won't have a democracy. One of 2 things will happen. Either that small group of rich people will establish an oligarchy and rule by the few, or the poor people will organize some overthrow of the rich people. The likely way this will be done is, in Lipset's view, the election of some sort of dictator, sometimes known as a plebiscitarian dictator, because the dictator who gained power through elections. The poor's resentment of the rich in this very unequal situation will lead to that kind of plebiscitarian tyranny. A second reason that spreading wealth contributes to democracy is that in a situation where lots of people have some money, the political values and style of the upper class won't be so sharply distinct from those of the lower classes. It may seem kind of funny to us now in the context, say, of politics in this country, where class distinctions and the sneering of the upper class at the lower class is very pronounced, that Lipset might think this was the trend of history. But at any rate, it seemed to him that when ordinary people were better off, richer people would have an easier time working with them, and that would make it easier for a democracy to be established. Furthermore, spreading wealth means that bureaucrats, people who work for the state, can be paid better, and bureaucrats who are paid better can think about rules. They think about what they're supposed to do, as opposed to lining their own pockets or taking care of their friends and family. This was Lipset's argument. And you can see here, of course, the influence of Weber's argument on bureaucratization that we talked about earlier. So, because bureaucrats start implementing rules when they're acceptably paid, that kind of bureaucracy is much more conducive to democracy. A bureaucracy that ignores the decisions made by a democracy is not one that enables anything like an effective democracy. And finally, Lipset thought that spreading wealth contributed to democracy because the most likely circumstances for a mass revolt that he thought would lead to tyranny, are circumstances in which poor people have nothing left to lose. In addition to these arguments for why democracy and economic development ought to go together, Lipset talks some about reasons why democracy and economic development might not always go together. So he doesn't take this trend, the trend of greater wealth, greater democracy, to be something that is a universal trend. It can play out in different ways in different circumstances. In what circumstances does rising wealth lead to democracy? Well, one of the things that's necessary for this to happen is that there needs to be some solution to the problem of legitimacy. What is it that makes government legitimate? And Lipset finds it pretty funny that in many democracies, some form of monarchy still persists. So he notes that 10 out of the 12 stable European and English-speaking democracies are monarchies. And he suggests that this correlation, the coexistence of monarchies and democracies, suggests that some form of monarchy is probably functional for the emergence of democracy. Another thing that Lipset thinks contributes to the emergence of democracy is a situation in which various kinds of political cleavages cross-cut one another. They don't overlap one another, but cross-cut one another. In particular, he describes three cleavages, three differences between groups in society that may express themselves politically. Religion is the first of them. The second is citizenship and entry into politics. Remember that the story of democratization or of democracy is, for a long period, a story in which there was a very small number of people who could vote, and that at some point there's an extension of suffrage, the right to vote, and mass franchise, and that creates issues of citizenship and entry into politics and a cleavage between those who have the right to vote and those who do not have the right to vote. And finally, distributional struggles or class struggles. What Lipset suggests is that when religion is overlaid on class struggles, or when issues of who gets to vote and citizenship are overlaid on class struggles, democracy will have a much harder time establishing itself. And if you compare Lubert and also the Lipset and Rakan argument that we talked about last week, you'll see that they too, both of those, rely on these three cleavages and investigate the effects of their overlapping or not overlapping. So here's how Lipset sums up his argument. You'll see that there are a lot of arrows here. On the left-hand side are things that cause democracy, and under open class system, it seems like he means a couple of things. A wide distribution, or a relatively wider distribution of wealth on the one hand, and on the other hand, a lack of overlapping cleavages that would reinforce a class system. These and various aspects of economic development contribute to democracy. On the other hand, in a democratic system, there are various forces that contribute to the persistence of democracy. So he has a theory not just of where democracy comes from, but also a theory of what ensures that democracy will persist. This, you will see, becomes very important to Zavorsky and his colleagues in the piece that you'll be reading for this week. So Lipset suggests that democracy tends to perpetuate itself in part by maintaining an open class system because everybody can vote, by maintaining equalitarian values, interestingly through political apathy because people may think it's not worth their while voting. People that don't participate contribute to the maintenance of democracy because they don't, in Lipset's view, make various sorts of obstreperous demands. So there are consequences of democracy that may tend to promote its continuation. All right, so in this section of the lecture, what I'm doing is setting out background you need to understand the readings for this week. But I want to make a little aside on the backdrop of that slide we just had to talk about the notion of parsimony. Parsimony is a word that people in the social sciences use a lot. Literally, parsimony just means an extreme unwillingness to spend money or to use resources. If you look it up in a dictionary, that's what you'll get. When, however, that term is applied to social science theories, it means something slightly different. A parsimonious theory is a theory that explains a lot with a little. It's a theory that has a small number of independent variables, but that explains some significant differences in dependent variables. Lipset's theory is not a parsimonious theory. As you recall from the previous slide, he had tons of factors that contributed to democracy. Many people who practice social science consider parsimonious theories to be worth aiming for. After all, if you just describe everything, it seems like you haven't explained very much. Nonetheless, it's worth noting that this is just an aesthetic principle. It's not a scientific one. There's not any generalization you can say that a better theory will always be simpler than a worse theory. Sometimes that's true, sometimes that's not true. Quantum mechanics, for instance, is much more complicated than Newtonian physics, but it is also much more accurate in many respects. So you can't say that a more parsimonious theory is always better than a less parsimonious one. That being said, it is a goal to which many people aspire. Let's get back now to our discussion of literature that will help you understand the readings for this week, and talk a little bit about how the discussion of democracy and development evolved after Lipset wrote. One case that was made was that democracy and development might not go together at all. And this case was made most famously by a man named Guillermo O'Donnell, a very good social scientist, passed away recently, but I always think of him fondly because at a conference I was at once, he pretended to be a monkey in order to amuse my little daughter, and I always thought that was quite cool since he was a very serious and famous political scientist. To pretend to be a monkey, I thought, showed remarkable self-possession, shall we say. Anyway, O'Donnell had this really interesting theory that he used to try to explain the emergence of authoritarianism in Argentina, which at the time that this happened was by one of the most developed states, possibly the most developed state in Latin America. And on this backdrop, it seemed very strange to people that it should have fallen into a dictatorship, since, on Lipset's argument, richer countries were supposed to be more democratic. How did Argentina get a transition from democracy back to dictatorship? And O'Donnell suggested that actually in the course of development, the possibilities for democracy change over time. In Argentina and in many other developing countries, the way the country industrialized was via something known as import substitution industrialization. What this meant is that they built factories that made stuff that they used to import. And when industrialization is happening, the working class expands, people become more productive and are able to make more money. Domestic demand is stimulated because people are earning wages and they have money to buy stuff. Put all of those things together, and economic policy can be very popular. Economic policy that contributes to import substitution industrialization, for instance, tariff barriers, can be very popular. And so it's easy to run a democracy in those circumstances when the working class is expanding and the economy is doing well. However, ISI tends to stop working after a while. It tends to stop working in part because the way that this industrial base is built is through importing foreign equipment. And at some point, that since you need to keep importing foreign equipment, but these industries that are substituting for imports, they serve the domestic market rather than the foreign one, countries start to run out of foreign currency. That's a short explanation of why you get the exhaustion of ISI, but that's not really important. The important thing is that when ISI stops working, the people who run a country that's practiced ISI have to start thinking about how can they make their economy more competitive. And at that point, they do things like squeeze wages to improve competitiveness. So this is going to be an unpopular policy and will lead to authoritarianism if it can't be done in a democratic environment. And indeed, if you have an economic policy that involves impoverishing most people, you would think that that would not be easily compatible with democracy, although the present-day circumstances in the European periphery suggest that there is quite a bit of space for impoverishment under formal, anyway, democracy. So that was an argument for why democracy and modernization might not always go together. Another line of argument suggested that democracy and modernization sometimes go together and sometimes don't. So this line of argument builds on Lipset's ideas that it might not be a universal tendency. Moore, Barrington Moore, whom Scotchpole referred to, you may recall from that reading, argued that only in countries with a strong bourgeoisie, a strong merchant class, will you get democracy. And Lubert, you recently read, argued that varied resolutions of historically emergent cleavages, in particular the issue of whether or not liberals were able to attain dominance in the 19th century and then how that shaped the politics of labor in the 20th century, they explain whether or not democracy happened. So both of these are arguments about the relationship between different social classes or different social groups and how that contributes to or does not contribute to democracy. So we can speak of these as theories of sociological preconditions. Now, both modernization theory, more wealth leads to democracy, and these sociological preconditions theories are fairly structural, which is to say, if a certain set of circumstances is in place, a certain structure is in place, you will get democracy as a result. However, not everybody believes that. Some people believe that democracy, the emergence of democracy, is neutral with respect to economic development and sociological structure, so this is called neutralism. Rather, democracy is explained by certain political conjunctures, or a political conjuncture just being a coming together of different political circumstances. So the story of democracy on accounts like this one is not a story of rising wealth. It is not a story of how different classes interact. It is a story of particular political events that can play out different ways in different circumstances. And this point of view was very influentially articulated by a man named Dankwart Rustow in 1970. And he said that what one needs is an argument that is genetic, which means it should explain causes specifically, not functional, which is to say it shouldn't just say democracy is a function of development. It's just not the case, Rustow argued, that social and economic factors always determine political ones. Instead, he says, it can be different in different circumstances. We don't have to be simple-minded about it, Rustow argues. We need not assume that democracy always happens for the same reason in this, wherever it emerges. So that you need not assume that the transition to democracy is a worldwide uniform process. Different issues can be on the table, different classes can be involved in different circumstances. Well, if all of that is true, how do you get a theory at all? I mean, he says, well, towards a dynamic model, but if it can be different, how are you going to get a model at all? Well, what Rustow tries to do is to talk about different phases of democratization in different countries and some sort of sets of political events that go together in a transition to democracy. It says you can't get a transition to democracy if there's not national unity, because the transition collapses into civil war, but if you have national unity, then you can get various phases of democratization. This approach that tries to look at the politics of the transition to democracy has been exceedingly influential, and later on in the history of comparative politics was formulated in game theoretic terms, and we'll read a little bit of that in the next week, something else by Jaworski. However, in what you'll read for this week, Jaworski and his collaborator Lemoyne, return to the classic Lipset question, and they say, what is it that produces the correlation between democracy and development? Along the x-axis here, you have per capita income in 1985 dollars. As per capita income gets above $6,000, almost all countries become democratic. So Jaworski and Lemoyne say, well, that could happen for a variety of reasons, and they try to set out in their piece, which you'll read, an explanation which doesn't depend on economic development causing democracy, but rather economic development helping to preserve democracy. Okay, so now we're done with the part of the lecture that has to do with background for the readings, and we're going to turn to our methodological section, and we're going to talk about some very basic statistics. Now, you will be a very diverse group in terms of your knowledge of statistics. Some of you will have taken a lot of statistics, some of you will have taken none at all. Some of you will feel very confident about your knowledge of math or maths if you use the British usage. Others of you will feel rather anxious about this. For those of you that are worried about this, that think you may not have enough math, I offer you this baby hedgehog, which is supposed to reassure you and make you feel calm. And in particular, of course, he's all prickly, right? But not only is he prickly, he's adorable, and so he's really not as scary as he might seem to be, and that is very much the case with this statistics that you're about to learn. So what is it that a statistical analysis does? What a statistical analysis does is it says, given some data on something you want to explain, so your dependent variable, try to come up with a formula that does a pretty good job of predicting that data using an independent variable or variables. So for instance, suppose we've got some data about our dependent variable y and the different values of x that go with each value of the dependent variable y. Can we come up with a formula that explains y in terms of x? So why would you want to do this? If you can make it work, if you can come up with such a formula that explains the dependent variable using the independent variable or variables, that is some evidence, not necessarily decisive, that the independent variables explain the dependent variable. So how do you go about it? How do you come up with a formula that takes data about the values of independent variables and dependent variables and spits out a formula explaining the dependent variable in terms of the independent variables? Well, the simplest way to do it is something known as a linear regression, and this is the only kind of statistical procedure that I'm going to talk about in any detail, and even with respect to this one, I'm not going to talk about it in much detail. A linear regression looks for the formula of a line that's as close as possible to all of the data points. It's also known as an ordinary least squares regression because the formula for distance involves squares, so you don't need to know any of that. Just know that OLS, ordinary least squares, is the same thing as a linear regression. Linear regressions, take note, by the way, of our hedgehog here if this formula freaks you out. Linear regressions operate based on the idea of a statistical model. A statistical model just means, what do you think the formula that connects the independent variable to the dependent variable is going to look like? That's your statistical model. I think that there is a formula, or I wish to investigate whether there is a formula that converts the independent variables into the dependent variable, and I think that formula is going to have a certain form. In a linear regression, that form is form of a line. So in a linear regression, you say that the dependent variable is equal to the intercept of a line plus some coefficient times the dependent variable. And because the prediction isn't going to be perfect for any particular value of the dependent variable, there will also be an error term. So this is just the formula for a line. This is where it crosses the y-axis at the intercept, and this is its slope with the coefficient. So this should be familiar to you from your high school or middle school math. So this shouldn't, I hope, be scary. Now what do? Once you've figured it out, what you think the formula is going to look like, you perform a complicated technical operation. You say, hey, computer, find me a formula for a line that predicts these y's using these x's. And if you look at this set of x's and y's that I've put up here, you can say, you know what, that kind of looks to me like there ought to be a line that goes through there. Computer, could you find one for me? And the computer can do that. In this case, it turns out that the formula for the line that comes as close as possible to predicting all of these things is y equals 2.0152x times minus 0.0291. Okay, so you see that there is a line that goes through most of these things. Now, when you ask the computer to do this sort of operation, it gives you a fair amount of information. It doesn't just tell you the formula for the line, it also tells you how good a job that line does of predicting the dependent variables. In the case of this regression, you can see that the line is pretty close to all of these data points, and that's reflected in a high r-squared value. R-squared refers to the share of variance, technical term just meaning the scatteredness, how close the line is to all of the data points. The closer it is to 1, the better. So let's just try to make sure we understand r-squared, the notion of how good the fit in a linear regression is, by looking at a couple of examples. Here's the line. We said, hey computer, get me a line that fits these data points. That's the line it came up with. That line has the formula y equals 0.68x plus 23.8. But it doesn't come very close to fitting all of these data points. And you see that r-squared is a lot less than 1. It's about a third. Here, on the other hand, is another regression in which the line comes a lot closer to the data points. In this case, it's 0.73x plus 19.2, and here the r-squared is 0.873. So you see r-squared is high when the points are close to the line, and it's low when they're far away. Here's a really high r-squared, 0.97, and you can see that the points are almost on top of the line. So let's just recap then what we've done so far. We've said that in a regression analysis, the investigator starts by proposing a statistical model, which is just what he or she thinks the formula that will best predict the dependent variables on the basis of the independent variables looks like. In a linear regression, that formula looks like a formula for a line. So in this particular one, the line has this formula, y equals 0.075x plus 17.37. The investigator told the computer, figure out what this coefficient and this constant are, such that my formula fits all of the data points as closely as possible. And in this particular regression, the computer was able to do that exceptionally well, as evidenced by the high r-squared. Okay, now let's look at an actual example of a regression analysis. This is drawn from the piece you'll be reading by Ross for next week called Does Oil Hinder Democracy? And you can see already there his independent and his dependent variable. He's interested in democracy as a dependent variable, and what he's particularly interested in is what's known as the resource curse issue. So the resource curse literature is a literature that examines whether natural resource wealth, especially oil, but also minerals, valuable stones, things like that, whether these sources of income somehow undermine democracy. So that's the resource course literature. Ross is making a contribution to it via a statistical study. So his independent variable is going to be oil, but if he wants to see whether it's really oil that hinders democracy, he's got to look at other possible explanations of democracy. And this is what he does in this piece, and he begins by setting up a statistical model. And this is his statistical model here. It looks complicated, but please don't get intimidated. It's really not very much more complicated than what we just saw. So let's see how he sets up his statistical model. He thinks that his dependent variable, which is regime, or how democratic a country is, he calls that his regime, is going to be predicted by a formula that has the following form. It's going to have a constant. It's going to have some effect for how much oil wealth a country has, how much mineral wealth a country has, how much income or how big the economy of the country is. It's going to be affected by the share of Muslims in the population. It's going to be affected by whether or not the country in question is a member of the OECD, which is an international organization of richer countries. The regime at any particular time, and you'll see that the regime has a subscript. Each of these variables has a subscript, so I means each individual regime, and then T at a particular time. His data consists of many, many observations of countries at different times and whether or not they are democratic and how democratic they are on his 0 to 10 scale. So he says that he assumes that a country that was a democracy or a dictatorship yesterday, or he actually uses T minus 5 years ago, is likely to be one today. So if he's trying to predict regime today, the effect of regime yesterday or 5 years ago is likely to be there. So he includes that in his independent variables as well. And then, just in case there are trends over time, he also includes the year that the observation was taken as an independent variable. Some of these variables are what are known as dummy variables. Their value is 1 or 0. Other variables have different possible values depending on how exactly they're measured. So this is his statistical model. It is him getting ready to ask the computer to come up with a formula that predicts his data. It's slightly more complicated than a line, obviously, because there's many independent variables, but the basic idea is similar. Each independent variable will be measured. The computer will calculate a coefficient for it that allows the best possible prediction of regime. You might be wondering, if he's interested in the effect of oil, why doesn't he just do a regression with oil? Well, he's got to consider, as I mentioned before, whether other things than oil might be explaining democracy. So one way sometimes people talk about this is to say he includes his variable of interest, oil wealth, but he also includes various control variables. These things are control variables, other things that might affect the outcome, but that he's not directly interested in. So what does the computer tell Dr. Ross when it's all done? Well, that's reflected on this slide. And the way people report regression results is they report the coefficients that go with each variable. So if you look at a regression table, it looks like what he's got over on this side. He runs a number of different regressions. We'll just focus on one of them for now. And what he's reporting next to each of these variables, so this is regime at an earlier time, oil wealth, mineral wealth, and so on. What he's reporting next to each of them is the coefficient. So if you were to write this out in terms of the formula we had on the preceding slide, you would say regime now is equal to the intercept not shown, but we don't care about that, it's not a causal effect, plus 0.253, so that's that coefficient times regime earlier, minus 0.0346 times oil, minus 0.0459 times minerals, plus 0.922 times income, minus 0.018 times the share of Muslims in the population, and plus 1.47 times the OECD. So if you just look at the sign of the coefficient, that's usually one of the first things people look at. The sign seems to make sense. Regime earlier has a positive effect on regime now. So if you were a democracy before, you're more likely to be a democracy now. You can, when you predict current regime, the regime earlier has a positive effect on your democracy score. The higher it is, your democracy score was before, the higher it's likely to be now. Oil, however, oil wealth has a negative effect on democracy. So that's what he was interested in studying, and the computer tells him that indeed oil seems to have a negative effect on democracy. Another thing that's reported on this slide is what's known as statistical significance. And you'll note that each of the coefficients has a set of stars next to them. And what the stars represent is explained down here. It's whether or not the result is statistically significant and how statistically significant it is. So what is statistical significance? Well, it's defined in the box here. It's the chance that the relationship between an independent variable and the dependent variable is an accident. Closer to zero is better. So the smaller the chance is, the smaller the chance that the relationship is an accident is, the more statistically significant that variable is. That's just the definition of statistical significance. All it means is how likely is it that this relationship is an accident. That may be confusing to you. What would it mean to be an accident? Well, imagine you were flipping a coin, right? It could come up heads 5 times in a row. Does that mean that it has heads on both sides, or was it just an accident? Well, you could figure out what the probability of a fair coin coming up heads 5 times in a row was and give some answer to that. So essentially, what statistical significance is measuring is whether the coefficient means anything, or it might just be an accident. And the lower the chance of an accident is, the more statistically significant a variable is. So you can see then that he's got 3 stars next to each of these coefficients. That indicates that there's less than a 1 in 1,000 chance that the computer thinks that there's less than a 1 in 1,000 chance that this is an accident. Now, one thing you would be likely to notice about this presentation of the regression analysis, if you had read some before, and maybe even after this lecture, is that there's no mention of R squared. How good a fit is this? Ordinarily, people report R squared, and if they don't report R squared, it's usually a sign the fit isn't very good. I actually wrote Ross and asked him why he didn't present R squared, and he said he didn't really remember. However, there's little chance that R squared in this particular study was low. It's probably a pretty good fit. The reason that I think it's probably a pretty good fit is regime 5 years ago is going to be a pretty good predictor of regime today all by itself. So anything it does better than that is probably going to boost the R squared. So there's every reason to think that R squared would have been close to 1 in this study. So now we know something about how to read the results of a regression. We've looked at Ross's statistical model, and we've looked at the coefficients the computer generated for him to measure the effect of different independent variables. Now I would like to ask you to remember something very, very, very important about statistics. We have this term statistical significance. It is extremely important to remember, absolutely crucial to remember, that statistical significance is not substantive significance. So, what is the difference between statistical significance and substantive significance? Statistical significance just measures how likely is it that the apparent influence of X on Y is an accident. What statistical significance doesn't measure is whether the influence of X on Y is important, whether the influence of X on Y is large. That is substantive significance. And you'll often see people say things, even in professional literature, but especially in popular presentations of statistical studies, in which they say there is a statistically significant link between X and Y. So you might read, for instance, that there is a statistically significant link between reducing saturated fats in your diet and living longer. But at least some people believe that if you look at the studies, that there could be a statistically significant result. It's not an accident. You really do live longer if you eat fewer saturated fats, but it's not a substantively significant effect. It's not necessarily an important one. So, for instance, a man who might otherwise die at 65 could expect to live an extra month if he avoided saturated fat for his entire adult life. If he lived to be 90, he could expect an extra 4 months. So that is probably, on the view of most people, not a large, important effect. It's statistically significant, at least if you believe the study that came up with this result. It's not an accident. However, it's also not large. It's not substantively important. So hopefully this illustrates to you the idea that statistical significance does not mean substantive significance. And anytime you see somebody say, well, there is a statistically significant link between X and Y, remember, that doesn't mean it's important at all. It doesn't mean it's large at all. All it means is it's not an accident. Now, you might wonder, how are we going to measure substantive significance in a statistical study? How are we going to decide what counts as a big effect? With the case on the preceding slide, that was easy to do. You just looked at how long people lived and what they needed to do to live longer, and we have some kind of intuitive sense about both of those things, whether we consider them to be small or large effects. But with your ordinary statistical study, you're not going to have that kind of easy, intuitive grasp about what counts as a small or a large effect. And in particular, you're not going to have an intuitive grasp of what counts as a small or a large change in an independent variable. You could say, well, not eating any saturated fats your entire adult life, that's a big change. That's a noticeable thing in one's behavior. But what counts as a big difference in the role of oil wealth in an economy? What counts as a big difference in the size of an economy for purposes of this kind of analysis? Well, to get some grasp of that, people who do statistical analyses use the notion of standard deviation. And all standard deviation is a mathematical measure of dispersion, or how scattered a set of numbers is. How much members of a set of numbers deviate from the average. And this particular formula for calculating it, you don't need to know that. You just need to get a sense that a standard deviation measures how spread out a set of numbers is. Suppose you were to flip a coin 100 times and count the number of times it came up heads. And then you did that over and over and over again and plotted the number of heads that came up. Well, you would have a small number of cases where heads came up, not very much, say 30 times. And then you would have a larger number of cases where heads came up close to 50 times, and then a smaller number of cases again where heads came up, say, 60, 70, 80 times, right? If you perform this experiment enough times, you would get all the different possible values of the number of times that heads could come up. You'd have to do it a lot of times to get 100 heads in a row, but if you did it to an arbitrarily large number of times, eventually you would. So if you have a random process like that, the frequency of different outcomes, so frequency of getting heads on 50 of your coin flips, frequency of getting it on 30 of your coin flips, and so on, forms what's called a normal distribution. So this is a picture of a normal distribution. The most likely outcomes are in the middle, and the less likely ones are out on the edges. And if you have a normal distribution, you then know something about the share of runs or trials of your coin flipping experiment that will come in within one standard deviation of the mean or average value. It turns out that 68.2% of all of your runs will come in within one standard deviation. So, standard deviation then lets you measure what counts as a big effect or a small effect. To say, if you were to flip a coin 50 times, 100 times, and you came up with 52 heads, that would not be a big deal, right? If you came up with 75 heads, that would be a big deal. So one standard deviation measures essentially whether or not it's a big deal, right? Whether or not it's a big change, whether or not when you're comparing two members of a set of numbers, there's a big difference between them with respect to that set of numbers. So that's what standard deviation does. It's not important that you understand it in detail, just that you understand the idea that it gives you a metric, a measure for deciding what a big change in some variable is. And in terms of standard deviation, we can then figure out what counts as a big effect. One way that people often do this for multiple regression is they plug in the average or mean value of each independent variable into the formula generated by the regression. So suppose the mean value for oil wealth was 0.5, you'd put that in the regression. You do that for all of the variables, and it comes up with some prediction of what the dependent variable should be. Then you change one independent variable by one standard deviation and see how much difference it makes. If it doesn't make a big difference, that means that there's not a big effect. If it makes a big difference, there is a big effect. So what happens if you do that for Ross? Ross doesn't do that in his piece. There are a couple of reports in there that are designed to give you some sense of how big an effect he's talking about, and you should keep an eye out for them. But he doesn't give you any systematic calculations. Oh, if you do those calculations, however, what you find is that the two biggest effects in substantive terms are lagged regime, which doesn't surprise you because, after all, whether or not you were a democracy 5 years ago is a pretty good predictor of whether or not you're a democracy today, and also income, or GDP. And so that doesn't surprise us either, in light of what we saw in the first half of the lecture. Richer countries are more democratic. What about the other things he talks about? Well, it turns out that the effect of oil is there, but it is noticeably smaller than the effect of regime. And one of his control variables, the share of Muslims in the population, has actually a bigger effect in hindering democracy, if you understand hindering democracy in the sense that he does. Want to make very clear, I'm not making a substantive claim here. I'm just talking about the results of this particular statistical study. That variable has a bigger effect than the oil variable he focuses on. So if he had done this substantive significance calculation, he probably would have had to talk about his results in a very different way. So this illustrates to you why it's really, really important to remember the difference between substantive significance and statistical significance. In general, you might not think that half a point on a 10-point democracy scale is necessarily a big deal. That's something that one could make an argument about. The important thing for present purposes is just to say that Ross does not present much of a discussion of the substantive importance of his results. So let's go on with a few important things to know about statistics. One is that statistical significance is not substantive significance. That's what we've just been through. Just because something's not an accident doesn't mean it's important. Second thing is that correlation is not causation. Just because two variables seem to move together does not mean one causes the other. For instance, if you went out on any particular morning and counted the number of people carrying umbrellas, that would be a very good predictor of whether or not it was going to rain later in the day. That doesn't mean carrying umbrellas causes rain. It means that people read the weather report. So those two figures, the percentage of people carrying umbrellas and the chance of rain, they would be highly correlated, but that doesn't mean one causes the second. So correlated just means goes together. This study revealed that there was a correlation between the share of Muslims in the population and less democracy. The fact that that correlation exists doesn't mean that there's a causal relationship. If you want to make an argument for a causal relationship, you need to make that separately. I tell you, you can get an enormous amount of mileage out of just remembering these two facts about statistics. If you can remember those two facts about statistics, you can have something intelligent and important to say about almost any statistical study. And really, those should be the first two things you ask about any statistical study. Do they have a good causal argument? No. And are the effects that this statistical study is talking about shown to be important in substantive terms? There are some other things that are useful to know, less important to know about statistics. One is that this is a pretty rough and ready way of approaching things. The linear model, the model where each variable has just a coefficient and that explains its effect on the dependent variable, it's not very realistic. We in order to get a 1-point increase in the democracy scale, you just multiply some independent variable by its coefficient. You change the independent variable enough, you get a 1-point increase in the democracy scale. But who says a 1-point increase in the democracy scale is anything meaningful? I mean, suppose that the difference between 4 and 5 is the difference between all men having the vote and everybody having the vote. And the difference between 5 and 6 is the difference between having poor vote counting and good vote counting. Who says that the causal processes, the causal effect of ensuring women's enfranchisement and ensuring good counting are the same sort of thing? This scale, if you're going to use a 1 to 10 scale like this, you're assuming that the motion, the thing that you need to get from one step to the next, the causal oomph, if you will, that you need to get from one step to the next is the same in each instance, and that is not on its face a very plausible assumption. Another thing that's important to remember is that a linear model is not appropriate for binary dependent variables. So if there's only 2 values a variable can take, like 0 and 1, you shouldn't use a linear model. So that's another thing to look out for. If you see someone seems to be using the kind of regression I've described today to explain something that only has the values of 0 or 1, they're probably not doing it right. One way that people deal with that problem of how do you do a statistical analysis of an outcome that can only be 0 or 1 is to do something called a probit analysis. You don't need to know anything about how this works. Just know that what it does is how it measures how the probabilities of outcomes change given changes in the independent or influencing variables. And this is the kind of analysis that Jaworski and Lemonnier do. They conceive of democracy as not on a 10-point scale like Ross does, but as a dichotomous variable. Either a country is democratic or it's not. And they then do a probit analysis, or it's a very similar thing called a logit analysis. And that enables them to figure out the way the different variables they investigate predict the probability of a country being democratic or not. Finally, I'm going to wrap up with some contrast between large-N quantitative research of the sort that we talked about today and small-N qualitative research that we've been talking about in the preceding weeks. They differ on a number of dimensions. First of all, they tend to specify their dependent variables differently. Large-N research, you need a numerical magnitude. In small-N research, you can have an outcome, which can be described in substantive terms, specific form, for instance, of the entry of the working class into politics, or it could be the presence or absence of a revolution. At any rate, the outcome doesn't need to be specified in numerical terms. Causal influence. How is the causal influence of the independent variables assumed to be exercised? In a large-N study, a change in the magnitude of the independent variable changes the magnitude of the dependent variable. So that's how the causal effect manifests itself. In small-N research, causes are thought of more like the Rube Goldberg device from the music video last week, where there's a set of causal steps and they add up to an outcome. So the influence of the independent variables is conceived of differently. Large-N quantitative researchers think that they need a lot of cases to establish conclusions. To some extent, this is just an artifact of the statistical method. The computer will tell you that you need a certain number of cases before it's able to do its thing to calculate the coefficients. So Ross uses a universe of cases. His are all sovereign states with populations of over 100,000 between 1971 and 1997. Small N researchers don't feel that they need to specify the scope of their theories so broadly. They use a limited number of cases chosen to provide instructive similarities and contrasts. This is a list of the cases that Skocpol uses. What about alternate hypotheses? This is an important thing. In a statistical study, the alternate hypotheses must apply to the whole range of cases. They're tested via the inclusion of control variables. So if you think that income might be a predictor of democracy, you test that against your whole range of cases. In small n research, investigators often test alternative hypotheses that apply only to particular cases, and they use historical research to figure out whether there are plausible alternatives. So, for instance, one of the arguments Skocpol found herself in was an argument about the role of the working class in the Russian Revolution, which some people felt like she ignored. The people who felt like the working class was more important in the Russian Revolution than Skocpol gave it credit for did not believe that that was true of the French and Chinese cases. They thought she got that particular case wrong, and she had to defend herself against, and even in the book you can see that she's thinking about this issue. She had to respond to that hypothesis that applied only to that particular case. Finally, data sources. In large N quantitative research, obviously you've got to rely on quantifiable data sources, and people try very hard to set up criteria that are very clear for how they measure things, make the judgment as objective as possible. But in small N qualitative research, there's no way of getting around the fact that the scholar's judgment is at the core of the enterprise. One has to select from historical materials, one has to build historical narratives, and these things require a kind of substantive judgment that you can't reduce to a recipe. So I think if you add all of these things together, you find that these two ways of thinking about what social science can accomplish and how it ought to be pursued are really quite different. And it's something I urge you to reflect on as you read the materials through the rest of this term. All right, that's it for this delayed lecture. Thanks for your patience in waiting for it, and apologies I wasn't able to deliver it in person. If you have any questions, please send them to me via email, and I'll try to prepare answers for everybody and circulate them over the Moodle list. All right, so long.